Well, good evening, everyone. My name is Dr. April Bolton, and I am Dean of the Graduate School at Hood College, one of the co-hosts of this fantastic webinar you're about to experience with Dr. Doug Tallamy. You're in the right place. I know we are seeing folks to continue to wander into our Zoom room, and that is most welcome. We are also streaming this webinar live on Facebook. And if you're logged in on Facebook, if you'd prefer that medium to experience the webinar, you're welcome to do so. Just do a search for Hood College Graduate School, and that will bring you to a single page where we are streaming the event. And we'll also put the link, the direct link, in the chat, again, if you prefer to stream via Facebook. It is my pleasure to introduce two of the co-organizers of tonight's event. Next up will shortly be Dr. Bernadette Roach. She's going to tell you a bit more about MACS and all of the wonderful work they are doing. Again, Hood was very grateful to be co-organizers with the leadership team at MACS. Their mission aligns with our mission, and very, very wonderful organization. So please give her your attention momentarily. After Dr. Roach, we will then transition to Dr. Sue Carney. Dr. Sue Carney was also one of the organizers for tonight's event. She is the program director for the Environmental Biology Master's Program here at Hood College. And it will be her privilege of actually introducing the much awaited speaker tonight. So with that, I will turn it over to Dr. Roach.
Hello. The Multi-Faith Alliance of Climate Stewards, MACS, is excited to share Doug Tallamy with so many people. And if making ecologically rich natural spaces is your love language, please go to Envision Frederick's webpage. That's envisionfrederickcounty.org to register for another talk in our wildlife series where Kerry Wickstead of DNR will talk about wildscaping with native plants. MACS has been working with local garden centers to stock high quality native plants, and we'll share those resources at the talk on April 18th at 7 p.m. I'm not going to talk a whole lot about MACS, but you can find us at our website, and I'll put the link in the general chat. Thanks.
Good evening. Doug Tallamy is an award-winning author and the T.A. Baker Professor of Agriculture in the Department of Entomology and Wildlife Ecology at the University of Delaware, where he has authored 104 research publications and has taught insect-related courses for 40 years. Chief among his research goals is to better understand the many ways insects interact with plants and how such interactions determine the diversity of animal communities. Through speaking engagements like this one, and best-selling books like Bringing Nature Home and his new one, Nature's Best Hope, Doug has brought his research to the public in an engaging manner. Take it away, Dr. Tallamy.
Thank you very much. Now we're screen shared. Well, happy to be here, everybody, and I'm glad you're here as well. Tonight, I want to talk to you about my idea of what nature's best hope is. But before I do that, I want to mention something that happened not this past fall, but a year ago fall. We had what we call an oak mast. Members of the red oak group all over the East decided to make their acorns at the same time, and this is what it looked like in an awful lot of places. Well, I am easily entertained, so I took one of those acorns and I stared at it, and I was rewarded. An insect started to chew its way out of the acorn. First, it chewed a hole for its head capsule, forced it through there, and then it forced the rest of its body through that tiny hole as well. It was a very tight squeeze, kind of looked like the Pillsbury Doughboy, finally dropped down. Very dangerous time for this insect larva because it is good to eat. There are a lot of things that are after it. So it's got to get to safety by squirming and wiggling below the surface of the soil in about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber converts itself to a pupa. Then it stays in that chamber as a pupa for 2 years. After 2 years, comes out as an acorn weevil. This is what a weevil looks like. Everybody thinks they have big noses, but that's actually an extension of the head capsule, and the mouth parts are way down here at the end of that extension. And they take those mouth parts and they chew a hole down into the center of the acorn, turn around and lay an egg in it, and that's how the larva gets into the acorn. We might wonder why they spend 2 years underground. Why don't they come out the very next year? Well, red oak acorns take 18 months to complete their development. So if they came out the very next year, there wouldn't be enough acorns for them. Well, once the acorn weevil is gone, that leaves the hole in the acorn, a true vacuum. And you know that nature abhors a vacuum. And in this case, she has filled it with 3 species of temnothorax ants, tiny little ants that live, their entire colony lives in the vacated holes made by acorn weevils. And if they find a new acorn, they're excited because their old acorn is falling apart. So they tell everybody it is time to move, and they get busy. They carry the larvae, they carry the eggs. They work very hard. Takes about 30 minutes for the entire colony to move into the new acorn. They post a guard to make sure nobody else comes in. And that's where they will live for the next 2 years until this acorn falls apart. Well, about this time, my wife says, "What's your point? What are you trying to tell us?" My point is that is only one of literally millions of very specialized interactions that comprise most of nature. This is another one, the relationship between jays and oaks. Jays are the primary disperser of oak acorns. They'll take an acorn from the tree, fly up to a mile away, then they tap it below the surface of the ground. The idea is that they're going to go back in wintertime and find that acorn to eat. But they can bury up to 4,500 acorns in the fall, and they don't remember where a lot of them are. So they end up really planting thousands of new oak trees every single fall. I found out this fall what is pollinating our witch hazel. Witch hazel, of course, is a shrub, small tree type thing that blooms very late in the fall, well after first frost. The leaves are all down. And everybody always wonders, what is pollinating witch hazel? The books say small flies and gnats, and I think they're making it up, because if you go out at night, it's really moths that are on there. There's a group of moths called winter moths. This is one of them, the bicolored sallow, that fly very late. I caught a bicolored sallow on Christmas Eve this year. So they turn out to be the primary pollinators of witch hazel. And I don't know whether witch hazel is blooming late to take advantage of winter moths, or whether winter moths are flying late to take advantage of witch hazel. But at this point, they're taking advantage of each other in a very specialized relationship. You won't have breeding pileated woodpeckers unless you have lots of carpenter ants, because that's what they rear their young on. And you won't have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have Facilia. That is the only pollen that particular bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We have about 4,000 species of native bees, and over a third of them can only reproduce in the pollen of particular plant genera. So for example, in this area, there are at least 13 species of bees that can only reproduce on the pollen of perennial sunflowers. You won't have Baltimore checker spots unless you have white turtlehead, on and on. Nature really is a series of specialized relationships. But today, those relationships, nature itself, is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, stood on the edge, looked out over the edge, and he said, "Leave it as it is." And with those 5 words, he started the formation of the Grand Canyon National Park. The problem, of course, is that leaving the country as it was is not an option. We didn't do that. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition. And that's because we have logged the country repeatedly. We've tilled it. We've drained it. We've grazed it. We've got 770 million acres of rangeland in the US, which is 4.5 times the size of Texas. And of course, we paved it or otherwise developed it. We've straightened our rivers and dammed them, and you can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We have depleted our aquifers. We have introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we have carved up the natural world into tiny remnants of its former self. And each one of those remnants is too small and too isolated from other such remnants to sustain the species that run the ecosystems that we depend on. Why have we done that? Well, imagine we thought the Earth, our nest, was so big that we could foul it forever and there wouldn't be any consequences. But of course, we were wrong about that. And that's why we're seeing pretty scary headlines like this at a regular clip. The insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about the global decline in insect populations. Followed by this one, North America's lost 3 billion birds in the last 50 years. That's a third of the North American bird population gone. And now the UN says, well, we're going to lose 1 million species to extinction, possibly within the next 20 years. And I love the way they report this, as if it's just one more headline. I mean, they might as well say, we're going to lose oxygen in the next 20 years, and then go on to the next headline. This is not an option, folks. It is not an option to lose oxygen or 1 million species. We have to make sure that doesn't happen. Well, I could go on talking about the pox that we humans have delivered upon the environment, thus upon all of our houses, but that's not what this talk is about. This talk is about a cure for that pox. It's a cure that'll take small efforts from lots of people, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, the great E.O. Wilson, Harvard emeritus at this point, most famous entomologist probably of all times, told us what it would mean if we were to lose insects. And he did it way back in 1987 with this paper, The Little Things That Run the World. His message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if our flowering plants would disappear, the energy flow through our terrestrial habitats would change so drastically that it would collapse the food webs that support our animals. The amphibians, the reptiles, the birds, the mammals, even many of our freshwater fish would have nothing to eat, and they would disappear. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that right now rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans wouldn't survive any of those drastic changes. The good news is that doesn't have to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on healthy ecosystems that produce what we call ecosystem services. We always think of them as these services keep us alive, but they also keep other things on the planet alive as well. What do we get from plants? How about oxygen? Pretty important. Plants are cleaning the water that we need, slowing its journey to the sea where it's too salty to use. Enormously important ecosystem service today is carbon capture. Plants are pulling carbon dioxide out of the atmosphere, out of harm's way, taking the carbon molecule out of, or the carbon atom out of that molecule, using it to build their tissues, and then pumping the extra carbon into the ground. Plants are also building topsoil, holding it in place, preventing floods, dampening severe weather, very important things. What are animals doing for plants? Well, they're providing pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds and many other things. So designing landscapes like this that destroy the production of ecosystem services is just a bad idea. It never was a good idea, but today with 7.8, 7.9 billion people on the planet, it's a terrible idea. We simply can't afford to waste space like this any longer. There have been visionaries through the ages who have recognized that we humans needed to work on our relationship with the only planet we have. And Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. One of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. Now, there have been some indigenous groups that have been able to do that for long periods, but our huge Western societies, our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another area, doing the same thing. And Aldo, of course, recognized that's not a sustainable relationship with the earth. So he had this idea that he called a land ethic. He dreamt that we would actually learn how to use the land. We have to use the land. We have to farm and lumber and graze and do all of those things. But that we would learn to do it gently enough that we wouldn't destroy local ecosystems. And that's what he called his land ethic. He wrote about it in the Sand County Almanac. What he never wrote about, though, was developing a land ethic where we actually lived. And I'm not sure why that was. I suspect, though, that the notion that humans and nature cannot coexist in the same place at the same time was so deeply embedded in the culture of Aldo Leopold's day, it's still embedded in our own culture, that he may not have even recognized it as an option. But what I want to argue tonight is that living with nature not only is an option, it is now the only viable option that's left to us. You know, that in the past, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to flip that on its head. We now need to save nature, actually reconstruct it where there are a lot of people, because that's most everywhere. In other words, we have to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, but thrive. Where are we going to do that? Well, places we can't ignore any longer are all the areas that are privately owned. Most of the country is privately owned, about 75% of the entire country, 85.6% of the US east of the Mississippi, privately owned. If we don't do conservation on private property, we're going to fail because we won't be doing conservation on enough land. There are areas, though, that we could be doing conservation on that we're really ignoring. How about power and pipeline rights of ways? There's 21 million acres in those types of landscapes. 3 million acres in railroad rights of ways, 2 million acres in golf courses, 3 million acres in airports. You know, the Denver airport is twice the size of Manhattan. These are big areas. Roadside, 17 million acres, and then all the places we live, both in rural areas, suburbia, cities, hundreds of millions of acres in those landscapes. If you add up just these, and you can think of other places, that's 599 million acres that we could be using for conservation that right now we're really not using. How big is 599 million acres? It's big. It's bigger than Vermont, plus New Jersey, plus Maine, Virginia, New York, Georgia, Florida, Oklahoma, Montana, plus California, even throw Texas in there. Not having a place to do conservation is not the issue. We can do conservation almost anywhere. When I talk about conservation, I'm using the term loosely. What I'm really talking about is rebuilding nature where we have deconstructed it. But not all species contribute to ecosystem function equally. So we need to use the building blocks, the most important species first, and then add other species later. And there are two groups of species that we can't ignore. We can't ignore those flowering plants. They're capturing energy from the sun, turning it into the food that then feeds all the animals on the planet. And you're not going to have those flowering plants unless you have the insects, the pollinators, that allow them to reproduce. So we need those. But once the food is locked up in the leaves of plants, unless it gets to the animals that need it, it's not going to do any good. Most vertebrates don't eat plants directly. They eat something that ate plants, and that something is typically insects. And it turns out that the insects that transfer more energy from plants to other animals are caterpillars. So if we design landscapes that don't have a lot of caterpillars in them, most of the energy is going to remain locked up in plant leaves, and you'll have failed food webs, failed ecosystems. Let's use the Carolina chickadee as an example. That's the bird. It's your feeder all winter long, where it's eating seeds. So people think, well, that's all it needs. Actually, 50% of its diet in the winter is seed. The other 50% is insects. But when it is reproducing, which will be just a few short weeks from now, their babies can't eat seeds. So they switch entirely to insects. And if they're in a healthy environment, they will rear their young entirely on caterpillars. And it turns out that they are not exceptions. 96% of our birds rear their young on insects, of our terrestrial birds, and most of the insects, it turns out to be caterpillars. How do I know that? Well, there's a couple lines of evidence, but this is a citizen science project that one of my grad students completed recently, Ashley Kennedy. She put out a call to bird photographers to take pictures of birds during the breeding season when they were carrying food to the nest. And the object was they're going to send the pictures to Ashley. She was going to identify what the prey items were in the beak of the bird and reconstruct the nestling diets of as many birds in this country as she could. And she got thousands of pictures from enthusiasts. She did identify the prey items. Many of these photographers are really good. And what you're looking at are the reconstructed nestling diets of 20 of the common bird families in North America. And the green bars are the percentage of those diets that are caterpillars. And in 16 out of the 20 bird families, caterpillars dominate the diet. So again, imagine what would happen if we took caterpillars out of the system. Most of our birds wouldn't be able to reproduce. So there's something special about caterpillars. What is it? Well, there's a number of things that are special about caterpillars. One of them is they're soft. They're soft prey items. Think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is exoskeleton. It's cuticle made of chitin. It's undigestible, so the birds don't want a lot of it. And because they're soft, you can stuff the caterpillar down the throat of your offspring without fear of injuring it. And if you've ever watched a parent bird rear their young, they're pretty rough. They take their beak, it's like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're nutritious. They're very high in fat, very high in protein, low percentage of chitin compared to most other insects, particularly beetles, which are not like little sausages. They're like little tanks. Much of a beetle is undigestible, and a lot of beetles have very sharp edges. And finally, it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. I mentioned carotenoids, not because I love organic chemistry, but because I'm a vertebrate and you're a vertebrate. Birds are vertebrates, and we vertebrates cannot make our own carotenoids. Only plants make carotenoids. So we have to get our carotenoids from plants, and we have to get them from plants because carotenoids are essential components of vertebrate diets. And that's why my wife, Cindy, makes sure I have a lot of carrots to get my beta carotene, and a lot of tomatoes to get my lycopene, a lot of whatever that is to get my lutein. And when I eat those things, they stimulate my immune system. And I can't think of a better time to have a very healthy immune system. Carotenoids are antioxidants. They run around our body, protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right. Turns out she was right. They improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this prothonotary warbler, who is bright yellow because he's had access to lots of luteins. And the brighter yellow he is, the more ladies he attracts. So where are they getting their carotenoids from? Well, the birds are getting it from, of course, the prey items that they eat, but carotenoid content is not equal across invertebrate prey items. The first two bars here are types of caterpillars, and they have far more carotenoids than other prey items. The third bar is orthopteroids, things like grasshoppers, crickets, and katydids. Here are the adult caterpillars way down here, the moths and butterflies themselves. They have far fewer carotenoids because they're not eating green leaves. It's the caterpillars that eat the green leaves where those carotenoids are. And here's the earthworm way down here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. This, with lots of other data, suggests that caterpillars are not optional parts of bird diets. It's looking like they are essential parts of bird diets, which means, let's just say birds need caterpillars. The next question is, how many caterpillars do they need? Is one or two enough, or one or two a day enough? Well, let's go back to chickadees. We have a lot of data on chickadees. How many caterpillars does it take to make a clutch of chickadees? The answer is one or two is not enough. It takes thousands of caterpillars to rear one clutch of chickadees, 6,000 to 9,000 caterpillars just to get into the point where they leave the nest. And then after they leave the nest, the parents continue to feed them caterpillars for another 21 days. But they're flying all around. Nobody's been able to count those. So you're really talking about tens of thousands of caterpillars to make one nest of a bird that's a third of an ounce. And if you want chickadees to breed in your yard, and we do want them to breed in our yards because in so many places that's all that's left, we have to have all those caterpillars in our yard because they forage about 50 meters from the nest. They're not flying 5 miles down the road to the nearest woodlot. And if we don't landscape in a way that makes all those caterpillars, that's called insect decline. And it's really looking like that's related to bird decline. We went to the original data set of Rosenberg et al. They're the ones that said we've lost 3 billion birds in the last 50 years and divided the terrestrial birds up into two groups. The birds that require insects at some point in their life history and the birds that do not require insects. So things like doves and finches can actually reproduce on seeds. Well, those seed eaters gained a few numbers in the last 50 years, but the birds that require insects on average lost 10 million individuals per species in the last 50 years. This doesn't prove cause and effect, but it certainly is suggestive that as insects go, so go our birds. I'm going to brighten my screen here temporarily. There we go. So we're really talking about if we want to have birds and all the other things that rely on insects, we have to start to landscape in a way that allows those insects to complete their development, especially caterpillars. It's the exact opposite of the way we've landscaped in the past. We've chosen plants that wouldn't support any insects. We thought plants were decorations only. They are decorations, but they have ecological function too. So what we now need to do is to design landscapes that support a lot of caterpillars. How do we do that? Well, you do that by adding the plants that make those caterpillars, that allow them to complete their development, which seems easy enough, but there is a catch. And the catch is that most plants don't make a lot of caterpillars. So we have to be very fussy about the plants that we choose. We have to choose the ones that make a lot of caterpillars, and we have to be fussy because caterpillars themselves are very fussy. And nothing illustrates it better than the monarch butterfly, but monarchs are not exceptions. Monarchs, of course, are only eating milkweeds. You can put all of the crepe myrtle and all of the Bradford pears and all of the boxwoods and camellias and burning bushes and all the other things that we plant from Asia in your yard, and you won't make a single monarch. You've got to have milkweed. That's called host plant specialization, and it turns out that the vast majority of insects that eat plants are host plant specialists. Why is that? Because plants have made them that way. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a very effective defense. It keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the plants that are out there, most of the insects that are out there cannot eat most of the plants. They are too well protected. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. Every plant lineage that's out there protects itself with a unique cocktail of chemical defenses. And any insect species cannot adapt to all of them. So they pick one or two and they get really good at getting around those defenses. They develop specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it takes a long period of evolutionary history with those plants for all those adaptations to fall into place. It doesn't happen overnight. And when they fall into place, the insect is then locked into eating only the plant lineage it's specialized on. It didn't take any evolutionary time developing adaptations to other plants. And that's why when we bring in plants from other continents, most of our insects can't eat them. Those plants haven't been here nearly long enough for our insects to adapt to them. So what I'm saying here is that plant choice matters. If we're trying to reconstruct viable food webs in all the areas where we've taken them apart, we need to choose the right plants or it's not going to work. And I'm going to give you 3 examples of how well it does work when we do choose the right plants. And I'm going to start with our house right here in Oxford, Pennsylvania. We have 10 acres of a farm that was broken up a few years ago. It was a very old farm for 300 years. And the last thing they did before they stop farming was to mow it for hay. So there were very few plants there. And our goal once we moved in was to put the plants back and build the biodiversity that was once on that site. So what we had to do was bring in the plants that support the caterpillars, that support the food webs that everything else depends on. Here are some examples. If I wanted the Canadian owlet, and I did, I'd never even seen a Canadian owlet. That's what the adult looks like. I needed to plant meadow rue. We didn't have any meadow rue, and there were very few plants there. As a matter of fact, I don't know of any meadow rue anywhere around here. The whole area was farmed to death for hundreds of years. So I got some meadow rue from someplace, planted it. The seeds grew very nicely. But this was early on, and I really didn't have a whole lot of confidence that Canadian owlets would be able to find my little patch of meadow rue. So I didn't even go out and check it. But about a month and a half after I planted it, I went out. They had grown very nicely. I just wandered by accidentally and it was almost defoliated. The Canadian owlets had found it right away. So now we have a good population of meadow rue and Canadian owlets. So we've added 2 species to the property. Same story with the goldenrod stowaway. It's a misnomer, it has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa, ditch daisy. I did know where there was some Bidens in a power line cut about 14 miles away. So I went and got some seeds. Planted them in our yard. They grew very nicely. It took about a year for the goldenrod stowaway to find our Bidens, but they did. Now we have a good population of both of these. So that's it. We've added 4 species to the property now. Same story with the Hackberry Emperor. I wanted Hackberry Emperor because it's a butterfly that ought to be here, but as its name suggests, and by the way, it's not the most beautiful butterfly, but that doesn't matter. I want it anyway. As its name suggests, it's a specialist on hackberry, and we didn't have any hackberry. So I planted hackberry. We had to wait 4 years for the butterflies to find our hackberry. They finally did, and now we have a good population of both of those. I walked by one of my hackberry trees last June, and on a single branch, there were 9 Hackberry Emperor butterfly caterpillars. So now we've added 6 species, and that's how it goes. I didn't plant goldenrod, came in on its own, and along with it came many of the things that eat goldenrod. Goldenrod in this area supports 110 species of caterpillars. Things like the brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. This is one that hasn't come, the goldenrod flower moth. And I don't know why it hasn't come yet. So that's what the caterpillar's like. This is anticipation. This is like waiting for the ketchup to come out of the bottle. It's part of the fun. Every year I go out, I look at my goldenrod trying to find these caterpillars. One of these years I'm going to find it, and that'll be a great day. Planted Virginia creeper. Yes, Virginia creeper. A lot of people don't like it, but I don't know why. It is a great plant. It can climb our trees without girdling them, without pulling them down, has good fall color, makes wonderful berries for the birds in the fall. It's actually an excellent pollinator plant. It's got little greenish yellow flowers that the pollinators really love. And it's the major host plant for many of our large Sphinx moths, which are the major component of cardinal diets when they're reproducing. Things like the Pandora Sphinx, and its beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. One of the double-toothed prominent, just because it's such a cool looking caterpillar. Well, it's an elm specialist. So I actually got some elm seeds from the University of Delaware, planted them, they grew very nicely. It's American elm, and the caterpillar came right away, big success. One of the evening primrose moth, because it's beautiful. I like beauty like everybody else. So planted evening primrose and waited a few years, but finally it came. The adult spends the day with its head stuffed in the flowers. It's very cute. And I planted a lot of oak trees. Now, these are just examples of the plant lineages we put in our yard. But I want to focus on oaks for a while because they're in such important plants. This is the Bedford oak in Bedford, New York. People argue about whether it's 400 years old or 500 years old. It's enormous. And, you know, I hear people say all the time, I'm not going to plant an oak because I won't live long enough to enjoy it. Well, if it has to be 400 years old before you can enjoy it, you're right, you won't. But if you can enjoy what your oak is doing for your local biodiversity, you can enjoy it right away. And I can say that with confidence because I planted my oaks, most of my oaks as acorns, some of them as 2-foot bare root whips. And right away, they started to bring particularly the moth caterpillars to our property that drive the food web on our property. Things like the solitary oak leaf miner, juvenile's dusky wing, the yellow-shouldered moth, the orange-headed epicalema, the red wash caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oak worm, the orange-humped oak worm, the pink-striped oak worm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crowned bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red line panapoda, the laugher, and literally hundreds more species of moths have come to the oaks that we have planted on our property, and they have come right away. This is a pin oak that just popped its head above the leaves, and here's a caterpillar standing on the ground eating the leaves of that oak tree. So you can enjoy the productivity of your oaks the very first year that you get them in the ground. This is what our property will look like in a month or two when the leaves come out. I'm sitting in this window right now. I show you this to prove we're very traditional. We got a little lawn here, but we have put a lot of plants back. And I noticed years ago that as I added plants to the property, new species of moths came. Remember, caterpillars transferring more food than anything else. Every time we add a new species of caterpillar, it's a good thing for our ecosystem. So I decided to take pictures, try to get pictures of every species of moth on the property just to see how many we had. I'm still doing it. And I'm up to 1,034 species of moths. That's more species of moths on our 10 acres than all the birds in the entire North American continent. And we do have 10 acres. Pennsylvania is 2.4 million acres. So on 1/240,000th of the land area, we have 40% of all the moths that occur in Pennsylvania. And because many of these are types of bird food, we have recorded 59 species of birds that have bred on our property. Not flew by, but bred. You know, we saw this headline this past fall. The World Wildlife Fund says that the Earth has lost 2/3 of its wildlife since 1970. I'm thinking, not at our house. I am sure we have increased biodiversity by more than 2/3, and it didn't take nearly that long, and we did it simply by putting the plants back. This works. So these are terrible, very frightening headlines, but turn it around. Let's turn it around. Let's all get busy. But I know what you're thinking. I have 10 acres. If you might live in a small suburban lot, will it work in small suburban lots? It's a good question. Well, let's go to Margie and Dan Terpster's house in Kirkwood, Missouri. In Kirkwood, Missouri, the major invasive plant is Amur honeysuckle, bush honeysuckle. So the first thing they did when they bought their property, which is 0.6 acres, 18 times less property than what Cindy and I have, is get rid of their bush honeysuckle. They're in the middle of suburbia, by the way. All their neighbors had the big lawns, a very typical suburban neighborhood. So they got rid of their invasive plants. They put in a number of native plants, and then they put in a water feature they call a bubbler. And then they sat back and started to count the birds that use their property. They're up to 149 bird species that have used their property, including 35 warbler species. Just to put that in perspective, we've only recorded 8 warbler species at our house. So yes, it works on smaller properties. What about urban properties though? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago, because right on the other side of this wall here is one of the runways of O'Hare Airport. Right over here is Kennedy Expressway. Pam has 1/10 of an acre that is not connected to any sort of wild area at all. So she's an island in Chicago. And 1/10 of an acre is 3 times smaller than the average lot size in North America. So she did the same thing. She got rid of her invasive plants, planted 60 species of native plants, and she did it quite well, and put in a water feature. Then she sat back and started to count the birds that have used her property. She's up to, out of date, 118 species of birds that have used her yard, including a woodcock. There's Pam's woodcock. So if you haven't seen a woodcock lately, go to Pam's house in Chicago. But what about cities? What about city centers? 82% of us live in cities. That's important. Well, in 2014, I was staring at this plant, Asclepius tuberosa, butterfly weed, which reminds me we have a marketing issue with our native plants. We call them weeds and wonder why people don't plant them. So let's not call this butterfly weed anymore. Let's call it Monarch's Delight. Okay, I was staring at Monarch's Delight in 2014, and the first thing I saw was 2 species of leafcutter bees. I know they're leafcutter bees, megachilid bees, because they carry their pollen on their tummy, not on their legs. Well, leafcutter bees have very strict requirements. They won't be in an area unless you have pollen and nectar, but you also need soft leaves. Leaves of redbud are perfect because they snip out the edges of those leaves into little semicircles, roll up the snipped out leaf and stuff it full of pollen, lay an egg on it, and that's how they reproduce. And they put that whole package in a crack or a crevice. Well, there was a redbud growing right next to Monarch Delight, and I'm sure that is why they were megachilid bees. It's probably why there were bumblebees there as well. Remember, bumblebees overwinter as queens. So when they come out in the spring, that's it. All they have is themselves. There are no workers yet. So they have to start the entire colony, and they need access to lots of very efficient foraging. So plenty of blooms, lots of nectar and pollen, and that's exactly what redbud supplies. Probably why they were bumblebees there. And then, this is all within about 20 minutes, I saw a monarch. I saw 2 monarchs actually that were foraging on Monarch's Delight. Now remember, this is 2014. 2013, I had gone the entire year without seeing a single monarch. That was the low point of the monarch population in the East. Only 3.6% of the population left compared to 1976. So I was excited. I mean, it really looked like the monarchs were going to disappear, but here, and this was June, it was early on. The monarchs don't usually get this far north that early. It was very encouraging to see 2 monarchs at this place. Why were they there? Well, there was Monarch's Delight, but there was another species of milkweed as well. I think it's purple milkweed. They had forage, they had nectar, but they also had their host plants. So they were there to reproduce. Do you know where I was? I was on the High Line in the middle of Manhattan. I was 30 feet above the taxis and the pavement. And that's the amount of nature that we're talking about here. It's a strip of plants along this converted elevated railroad that they've turned into a tourist destination that millions, literally millions of people visit every single year. So despite the traffic, despite where it's located, all that those things came to this little bit of nature. This is Rick Dark. He was always after me to go to the High Line and see the beautiful plantings. I'm not much of a city boy, so I always drag my feet, but he finally got me there. But you know, I expect to see beautiful plants with nothing using them, which to me is actually depressing. But I was wrong. I was totally wrong. I saw all that I showed you in 20 minutes, including those rare monarchs. Somebody has just finished a survey of the bees on the Highland. They're up to 30 species of bees that are using it. So I'm convinced if thoughtful native plantings can bring life back to the middle of Manhattan, I think we can do this just about anywhere. There are 4 things we need to think about, though, if we want to succeed in a big way. And the first one is we have to shrink the area that we have in lawn. We have more than 40 million acres of lawn nationwide, which is the size of New England, dedicated to a deadscape. It's a, it's a status symbol, and I get that, but we can demonstrate our high status with our manicured lawns, but have less of them. If we replant half the area that's in lawn with productive plants, even though we keep some lawn, if we do that really half the area, that's going to give us 20 million acres to work with for conservation. And if we do that at home, we can create a new national park that I'm calling Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badland National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. So Homegrown National Park will be the biggest park in the country. What do we get when we put a park at home? We get the opportunity to develop a personal relationship with the natural world. Maybe you had one as a child, but if you've lost it, you can reacquaint yourself with nature, and you can do it at your own time and your own pace. You can avoid crowds. If you go to a real national park, there are millions of people there. So you're really visiting millions of people. It's also free. There's no admission fee, and it's never closed, no matter what pandemic comes down the pike. No travel hassles. But again, you get to experience the natural world alone. And this is really important for our poor kids who Richard Lewis says they're suffering from nature deficit disorder. So we have to get them out of the house into natural systems. That's hard in a lot of places. So what are we doing? We get 30 kids with a teacher, put them on a bus, they drive for an hour, and they walk around a natural area for an hour, and teacher tells them not to touch anything. Then they get back in the bus and they go home, and that's their experience with the natural world, which I'm sure is better than nothing. But it's really an experience with 30 other kids and a teacher telling them not to touch anything. If they have some nature at home, they can go outside by themselves, alone, no parental supervision. Let them discover life the way they want to. They'll develop that relationship, which is so important because they are the future stewards of the planet. And if they don't have a personal relationship with the thing they're supposed to be stewarding, they're going to be lousy stewards. And maybe they will learn how to hunt lizards. I'm learning this from my own granddaughter. This is Zoe, who lives in Hawaii on a very modest piece of nature. It's a little patch of grass with a hedge, but there are no lizards there. And she discovered that. And she also discovered how to hunt those lizards and sent me this picture to explain it. You get on the ground, you disguise yourself with leaves and sticks so the lizards can't see you coming. And then you crawl very slowly toward the lizard. No smiling. This is serious business. You can wear your best dress, that's okay. But you sneak up on the lizard, you catch the lizard, and you put it in an aquarium. And there's your personal relationship. Now, I don't think Zoe's going to be crawling on the ground catching lizards in her best dress the rest of her life. I don't think. But I guarantee she's going to remember catching lizards in Hawaii the rest of her life. And I also guarantee she's going to be a good steward of the planet, in part because of that. If you want your kids to do more than catch lizards, get this book by Nancy Strunisti, Nature Play at Home. Dozens of examples of how to expose your kids to the natural world right where you live. And if you want to join Homegrown National Park, go to our new website, homegrownnationalpark.org, and get yourself on the map. The object is to record where you live and the amount of area you're converting to natives, and it will light up your part of your county. This is our attempt at social media to try to get competition, reach beyond the choir. There are millions of people who don't seem to know anything about this. So that's what this is designed to do. Maybe have a competition between Maryland and Pennsylvania. Anyway, we'll see how that works. There are over 4,000 species, 4,000 people who are on the map at this point. So get yourself on the map and join the crew. All right, we're going to shrink the lawn. What are we going to put where there was lawn? We're going to put plants, of course, but which plants? Some of them have to be what I'm calling keystone plants. Now remember the Roman arch? The keystone is the stone right in the middle of that arch. And if you take it out, the arch falls down. Well, if you take keystone plants out of the local food web, the food web collapses. That's because they are so important in terms of making food. They're just 5% of our native plants, make 75% of the caterpillar food that drives those food webs. 14% of our native plants make 90% of the caterpillar food, which means 86% of our plants are contributing, but not all that much. So think of the keystone plants in your landscape. Let's say you're building an ecological house at home. The keystone plants are the 2x4s of that house. You can't build a house out of wallpaper. It's going to fall down. You need those 2x4s. So they're essential. They're not sufficient. You need to add other things, but they are essential. So the question no longer is simply, are natives better than non-natives? On average, they certainly are, but there are a lot of natives that don't support a whole lot. We've got to focus on those ecologically productive ones, the real powerhouses, or we're going to fail. And they're certainly going to be better than ecologically destructive ornamental plants that have proven to be invasive. Those ones from Asia, things like burning bush and barberry and calorie pear, you know what they are. They escape our gardens. They're biological pollution. They ecologically castrate the land around us. I get an email twice a year from somebody who says, don't you know that ginkgo biloba from Asia actually grew in North America 7 million years ago? That makes them native. That means we can plant them and everything will be great. Yes, I do know that ginkgos grew in North America 7 million years ago. We can argue about whether that makes them native today, but I'm not going to have that argument because this is not our metric anymore. I don't care whether it's native or not. I care whether it's productive or not. I don't care if ginkgos grew in the moon 7 million years ago. Today, they produce 0 species of caterpillars. There are 2 rare records of caterpillars munching on ginkgo leaves, but nobody's ever collected them. I've never seen them. This is what a ginkgo looks like. So it's standing there, but it's not producing anything. If you want a tree that's going to actually support the wildlife around you, there's no better plant genus than oaks. The #1 keystone plant in 84% of the counties of North America. In the mid-Atlantic states, they support 557 species of caterpillars, 557 species of bird food, 900 species of caterpillars nationwide. Again, no other plant genus comes close to that. And this is the role of keystone plants, keystone oaks in my yard. I remember so far I've taken pictures of 1,034 moth species. Haven't gotten to the butterfly yet. I'll get there. Out of the 1,034 species, 910 have known host plants. Out of that 910, 270 species use oaks. And we have 69 genera of native woody plants on our property, and only one of them is Quercus oaks. And we have hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of our woody plant diversity and way less than 1% of our total plant diversity, but they're supporting 30% of our moth species diversity. So imagine what would happen to the diversity at our house of not just moths, but the things that depend on them if we took oaks out of the system. That's the role of a keystone plant. How do you find out what the keystone plants are where you live? You go to Native Plant Finder on the National Wildlife Federation website, put in your zip code, and the ranked list of both woody and herbaceous plants that are ranked in terms of their ability to support caterpillars pop up for your county. So the old excuse of not knowing what to plant is gone. We do know what to plant now. All right, we're going to shrink the lawn. We're going to put in keystone plants. We're going to attract a lot of insects to our yard. Then we're going to kill them with our security light. Of course, that's not the goal. There's a lot of research coming out now at a regular clip, a lot of it from Europe, that's pretty convincing, saying that light pollution, the lights we have on at night, are one of the major causes of insect decline. They kill insects through exhaustion. You know, the moth flies around and around and around until it drops. Collisions with the bulb, they get incinerated, they die from dehydration. The bat comes and eats them when they're at the light. Bright lights blind a lot of nocturnal insects, and it keeps them from doing what they ought to be doing. You know, to me, this is actually really good news. We have to turn around insect declines. It is not something we can tolerate. It's not something that is acceptable. This gives us an easy way to start doing it. Just turn out your lights, flick up a switch. What could be easier? I know what you're going to say. Well, I can't turn out my light, my garage light, because the bad man will come. Okay, put a motion sensor on your security light, so it only turns on when the bad man does come. And the first thing you'll discover is that the bad man doesn't come very often. And if you don't want to do that, take the white bulb out of your security light and put in a yellow bulb. Take that mercury vapor bulb out. That's the very worst because it's so attractive to insects. Put in a yellow bulb. A yellow LED bulb is the best because they are the least attractive to insects. If we switched out our white lights for yellow LED bulbs overnight, we could save billions of insects and billions of dollars too, because these, of course, are far more energy efficient. Fourth thing we have to do is we have to allow caterpillars to complete their development by landscaping appropriately under the trees in which they develop. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. So the caterpillar eats the leaves, then it spins a cocoon and hangs from the branches of the tree. Then it emerges as an adult and then does it all over again. I wish everything did that, but most things don't. 480 species, 94%, they'll finish growing as a caterpillar on the tree, but then they drop from the tree and they wiggle their way beneath the ground, pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree, and the ground is mowed and compacted so hard that the caterpillar can't get under the ground. So this becomes an ecological trap. It calls in the adult moths to lay their eggs, the caterpillars develop, and then they drop down and die. And the next generation is smaller, and the generation after that disappears altogether. And you know that this is the way we landscape everywhere. I am convinced that the inattention to the land under our trees is another major cause of insect declines, at least in this country and probably around the world. The cement landscape, of course, is even less of a viable option for caterpillars. And I'm not trying to discourage the use of trees in cities. I'm trying to discourage the profligate use of cement in cities. We know it's a bad idea. We know that it destroys watersheds. We know that cement releases a whole lot of carbon dioxide, a greenhouse gas. This is just laziness. This is what most people do. They put a big tree in the middle of the lawn. Now, nobody's nobody's recorded the ability of caterpillars to survive in a situation like this. But I guarantee they're going to survive better in a situation like this, where you have a tree and then a layered landscape, maybe a dogwood over here, and then a native azalea and ferns and ground cover. Caterpillar drops down to a safe site. The ground soil is not compacted. They can easily get below the ground to pupate, or they can spin a cocoon in the leaf litter underneath these plants. Their survivorship will be much higher. This is where you can do your spring ephemeral gardening at the base of your trees. This is how you shrink your lawn, folks. You plant around your trees and all of a sudden you got less lawn. Safe sites. This is where you can use your ground covers, things like wild ginger or mayapple or foam flower, ferns. This is a hotel in Athens, Georgia. These are red maples. So if a caterpillar develops on these red maples, they drop down, they're in a safe site. Maybe they'll actually make it even though they're in the middle of a city. Another grad student, Desiree Narango, has done some wonderful work with chickadees in the suburbs of Washington, D.C. And the results of her studies suggest there is room for compromise in our plant choices. And that's good news to me. She compared the ability of landscapes to sustain chickadee populations when they are dominated by native plants versus when they're dominated by non-native introduced plants. And that's typically what we landscape with. The first thing she found is that the landscapes that are dominated by introduced plants produce 75% fewer caterpillars. So the bird food has been reduced by 75% in those landscapes. They were 60% less likely to have breeding chickadees at all. Now, there are nest boxes up in each property, but the chickadees would come and look around and say, there's simply not enough to eat here. We're not even going to try to reproduce. If they did try to reproduce, those nests contain 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. The nests, if they did survive, produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. And if you put all those numbers into a population growth model as a function of the percentage of non-native woody plant biomass in your landscape, this is what you get. This is replacement rate. This is the rate at which the population has to make babies to replace the adults that die every year. If you reproduce at this rate, it's a sustainable population. You're not growing, but you're not shrinking either. If you make more babies than adults die, you have a growing population. But if you're below this line, you make fewer babies, That's a unsustainable population. The population shrinks every year. Right here, generously speaking, is where those lines overlap, which means we can have up to 30% of our woody plant biomass non-native, as long as they're not invasive. We can't tolerate invasives, but you can have your ginkgo, you can have your crepe myrtle, you can have your boxwood. Those are not invasive species, as long as they don't dominate the landscape, as long as 70% of the woody plants in your landscape are productive native plants. And that's good news to me, because if my message was we can't have a single non-native plant out there, very few people would be listening. It's not the presence of non-native plants that destroys food webs. It's the absence of native plants. So if we increase the percentage of native plants in our landscapes, we can tolerate non-natives. Can we use native plants in formal designs? Of course we can. Somebody sent me this picture from North Carolina, and what they're doing is replacing, this is a formal landscape, and they're replacing all the species with native species. So they got Joe Pye in here. Notice I didn't call it Joe Pye weed. It is not a weed. Remember, a weed is a plant out of place. Our native plants are not out of place, even in formal gardens. And when they replace all of the plants, they're going to send me another picture. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe all the time. And I guess that's okay because they're non-native plants there. Can we get a pollinator garden into a suburban yard like this without insulting anybody or upsetting anybody? Of course we can. Let's just put a fence around it. It makes it totally socially acceptable. There's a number of species here. It's helping a number of species of native bees. It's not very big, but if everybody does it, you've got a lot more forage in your landscape than you had if everybody didn't do it. Let me quickly remind you why we need pollinators. It is not because they pollinate 30% of our agricultural plants. They only pollinate about 12% of our agricultural plants. And a lot of people think, well, if I don't live next to a farm, I don't need any pollinators. Not so. Our pollinators are pollinating 80% of all plants and 90% of all flowering plants. If we lose our pollinators, we lose 80 to 90% of the plants on the planet. Not an option. Where do we need those pollinators? Everywhere. Everywhere we need plants, including our yards. What about this design? A Drew Latham design. It's much bigger. Imagine the amount of life that is supported here compared with the amount of life supported right over here. Seems like a no-brainer. Can municipalities help us live with nature? Of course they can, and more of them are doing it. Minnesota has a cost-sharing plan program that encourages homeowners to reduce the area of lawn by putting in appropriate Minnesota prairie plants. You get paid to do that. Pennsylvania, I just learned about this 2 weeks ago. The very impressive lawn conversion program. You get up to $5,000 per acre to convert your lawn into a real habitat. I think Maryland has a similar program. Florida, there's an island of Florida where the municipalities paying residents to allow burrowing owls, listed species, to burrow in the front yard. You get paid to do that. That's the way the Endangered Species Act should have been written, with carrots rather than sticks. So that if you have an endangered species on your property, you get paid to take care of it. You don't get fined just because you're using your property. Missouri and Fayetteville, Arkansas have a bounty on calorie pears. One of the most invasive plants we can put in there. Take out your calorie pear and you get a free tree replacement. Even public utilities are getting into the act. They're giving people in San Antonio $100 coupons to rip out their water-thirsty non-natives and putting in native xeric water-adapted plants. And we have, of course, those big lawn conversion programs in California, up to $2 per square foot rebate if you take out that thirsty lawn and put in xeric plantings. You know, I think we've made 3 missteps in the early years of conservation. And this is the first one. We haven't looked at nature as if it's essential. We like it, we think it's important, but not essential. And that means if when push comes to shove, when resources are in short supply, which is always, nature takes a back seat. I went to the Cincinnati Zoo before the virus broke out, and there's this wall-size poster there that epitomizes, I think, our society's view of conservation. We want to save wildlife for future generations. That was Teddy Roosevelt's argument for making the national park systems. They're such magnificent places, we need to save it so future generations can enjoy it. And I certainly agree with that, but it suggests nature's there just for entertainment. No wonder we don't think it's essential. Entertainment's not essential. But nature is essential. We need to save nature so that we have future generations. A little bit more urgent. Second misstep is that we've assumed that humans and nature cannot coexist. Now, we talked about this. If we restrict conservation just to areas where there's not a lot of humans, we're going to fail because those areas aren't big enough and they're not connected enough. They're totally separate from each other. David Quammen has a wonderful analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are operating or functioning like a Persian rug. And that's exactly what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. But I hate that language because it suggests there's places on planet Earth that have no ecological significance. Not so. Every square inch of the planet has ecological significance. Even your yard, even the corporate landscape next door, even our roadsides. So we need to put our plants back together again. We need to glue our ecosystems back together again with those powerhouse plants. I'm not just talking about making biological corridors that will allow plants and animals to move back and forth between ecosystems. I'm talking about making viable habitat right now where there is none, which means we're going to have to start to share our landscapes, where we live, where we work, where we play, and to a lesser extent where we farm. Our third misstep was to leave Earth stewardship to just a few specialists, a few ecologists, a few conservation biologists. We didn't see it as an inherent responsibility for every human being. But I don't know why. Every person on the planet depends entirely on the quality of Earth's ecosystem. So why wouldn't every one of us bear the responsibility of good Earth stewardship? Stan Rushworth once said that the Western settler mindset, here's a Cherokee elder, by the way. Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with those mindsets, you're taught them. And we're very good at teaching this one. We have been terrible at teaching our kids what their obligation is to planet Earth and what our peers' obligation is. It doesn't mean you have to save biodiversity for a living, but we really can save it where we live. And I like this approach because it empowers each one of us. You know, right now, a major problem is that we all feel powerless. And I don't blame us. I mean, the Earth's problems are huge. But this is something that each one of us can do alone. The individual can make a difference. The cliche is correct. You can go outdoors, plant that oak tree, plant any of the keystone plants, shrink your lawn, get rid of your invasive species, put in your pollinator garden. A single person can do that. You will create a functioning ecosystem right where you live. Your little piece of the world will enhance local ecosystems instead of degrade them. And it makes you an important cog in the future wheel of conservation. It also shrinks the problem down to something that's manageable for each one of us. Don't think of the entire planet's problem. You'll get depressed. Just think about the piece of the Earth that you can influence. If you own property, that's obvious. That's where you start. If you don't own property, help somebody who does. Volunteer, help a land conservancy, help a park or preserve. They're all underfunded, understaffed. They will love you. So as property owners or as volunteers, each one of us has the power. We certainly have the responsibility to fix dead landscapes like this. Whether or not we decide to do so is going to determine nature's fate and ultimately our own. I think I've convinced my grandchildren that you are nature's best hope. Hope I've convinced you as well. Thanks very much.
Thank you, Doug, and thank you all for attending. On behalf of the Hood College Environmental Biology Master's Program, I would like to thank MACS for their partnership in sponsoring and organizing this webinar. And of course, we thank Doug for his informative and inspiring message. This session was recorded with permission from Dr. Tallamy and will be available on YouTube in the coming week. Good night.